All right, recording is rolling. Welcome to Tuesday, September 19th. I have a friction lab lined up for you guys. Before I jump into that, here's a top scientist for projectile motion. So awesome job if you were on that list. I haven't handed the quizzes back yet. I'm still waiting for a couple of late ones, but yeah, you guys got that. Awesome job if you're there. Okay. So, all right, friction lab we're going to do today. I did go ahead and print out a page today because we need to save well, we need every minute of class we got here today. Okay. All right. Also, oh, whoops, I forgot to have this out. Okay. Okay. I meant to have that out when I was hit record. Okay. Here's some upcoming due dates. Okay. AP Classroom. You guys will have that done by Monday when you guys come to class. Monday. That's where you go. Okay. Then these chapter 4 puzzles, I did some of those with you guys yesterday. Those aren't due until like the next Friday, so almost 2 weeks from now. Okay. And I did here when you guys walked in class today, you guys got one of these quizzes on your desk, this dynamic quiz, right? So I'm giving you guys this like way earlier than I usually do, but just a few reasons. So anyway, you guys got this, but this is due Monday, October 2nd. Okay, Monday, October 2nd. You guys get this next take-home quiz, right? So plenty of advance time with that. All right. Let's see, what are we doing with friction? So we did some stuff with friction yesterday, and this lab is going to be in 2 halves. And the first half is like this more like straightforward classic way of thinking about it. So remind you guys what this looked like yesterday. Okay? So suppose you have a weight, and you lift it with one of these spring scales, and it weighs some amount. Okay? And then you drag it at constant velocity across the surface. Right? Might want to use the blue spring scale for that, especially for some of these smaller ones. Right? Get some of the smaller values, right? So drag at constant velocity. Ooh, here's the free body diagram exactly for that scenario, dragging at constant velocity. That's constant velocity. Is that equilibrium? Yes, it is. Because what's the acceleration? 0. Therefore, the net force is 0. Therefore, all the force vectors better cancel out. I see 4 forces on this block, dragging at constant velocity. There's the weight, but it's definitely not in free fall because there's a support force on the surface called the what force? Normal force, right? Those are definitely balanced out in the vertical direction. Right? And then you're pulling with the force, so you're applying force. You can read that straight off the spring scale. Right? But that's, okay, yeah, constant velocity must be balanced out by the friction. So whatever reading on the spring scale, and guys, what are you reading on the spring scale? Grams or newtons? Newtons, the Newton side, because you're measuring force, right? That must be also telling you what the friction force is, as long as you're pulling constant velocity, right? Wouldn't that be true? Right. And there's some coefficient of friction between these 2 surfaces. Now it's a material property. So if I have like this bare metal versus this paper, right? There's some coefficient of friction that's the ratio of these 2 forces here, friction force compared to normal force. Now that's a material property. So once you know what materials you're working with, it's going to be some ratio. Right? We're just going to focus on the kinetic friction today. Not worry so much about static today. Okay, you guys got that coefficient kinetic friction, right? Or a lot of times how you see this and how AP has it on their own page is if you cross multiply the normal force, you can calculate the friction force. If you know the coefficient of friction and the normal force, you just multiply these 2 together to get this guy. That be true, right? And now, if you guys look at this and you know something about equilibrium, the ratio of these 2 forces, isn't that also the ratio of these 2 forces, right? The spring force compared to the weight, it'd be like the same ratio, wouldn't it, for this particular setup, right? Hold on to that idea, right? Remind you guys too, you guys saw this yesterday. So again, like once you know what materials you're working with, right, there is some known like coefficient of friction, right? Again, we're going to focus on the sliding friction, right? There's also static friction, right? You guys know that? One particular application of this, we did this yesterday, right? You guys is here, know this, be able to know this, right? It's like how fast can a car brake, right? How fast can it slow down? So acceleration maybe a negative value that's driving positive direction, right? As long as coefficient of friction and the gravity field that it's in, right? You can prove it. Here's the proof right here. Be able to do this because I wouldn't be surprised at all if that could be like an FRQ, AP asks you, and May, right? Okay, this is getting to like the second half of the lab. We're gonna hang tight on that, right? So let's look at first half lab. Help you guys out a bit here, right? I did print out the table just to save us a few minutes. So we've got different weights. You guys got a whole box of lab weights in front of you. I'm gonna make up stuff like the 50-gram lab weight. I bet if you pick here, all right, I pick up some in front of me. Let me just show you guys, right? Here, this is 200 grams mass. If I pick it up with the spring scale, it's reading 2 newtons of weight. You guys see 2 newtons of weight? So under weight, I'll go ahead and know that there's a 2 Newton weight, right? Let's say you get some other ones. This 100-gram mass, I bet that's half of that. It's like 1 Newton of weight, right? I bet there's a half Newton weight somewhere around. I bet there's a 5 Newton weight somewhere around. I bet there's a 10 Newton weight somewhere around. I'm just kind of making up numbers, but I get that those match someone's in their box, right? Now, how much force would it take to drag this at constant velocity across the surface? Okay. See if you can kind of control for materials today. Some of those lab weights might have some black paint on them. Maybe that would make it a little bit different category. Okay. Okay. But do you guys see if you know the drag force compared to the lift force? Go back to this. The drag force compared, the drag force compared to the weight, right? That's also like the friction force compared to the normal force, which is could tell you the coefficient of friction, right? You guys it? All right. So, right. So you guys remember the concepts, how this is working, right? So here, big picture then, and I've got you guys started here. Suppose this took like you say like 0.7 newtons, I guess. I'm just making something up. 0.7 newtons to drag it across. I embedded the unit in the titles up here, right? So these are all in newtons, okay? Okay. So big picture here is that there's actually more than one way you can find coefficient of friction. And I've been leading you guys through like the straightforward way, but that's just the first half of the lab. I'm going to have you guys do a write-up, an AP style write-up. And at the end of class today, before the bell rings, I'll go through and have you guys score it. I'll let you guys pick, though, which write-up you want to do. We're going to do 2 setups. We're going to do one that I've been taking you guys through. So we'll do second setup later that involves the block sliding at constant velocity down the incline. It turns out that you can determine coefficient of friction with nothing except a protractor. That's going to be the second half of lab today. So I'll have you guys go ahead and get data for this and graph for this, and same thing for this, data and graph, right? All guys, walk here, and about the last few minutes of class, here's the 5-part write-up. Right, it's the same 5-part regardless of what, right? So question, everybody's got the same question. What's the coefficient of friction between 2 surfaces, right? Say the lab weight and the desk, or lab weight and paper. Maybe, I think paper's a little easier because you have to apply more force, so it reads better on the spring scales. Maybe I should say paper here, right? The weight and the paper, okay, right. Measuring tools, pick one or the other. If you do the entire lab with the spring scale, you can do that, and it's what I've been showing you, right? Lift, drag, boom, boom, okay. Or you can choose the protractor. Right? Now, the protractor has something to do with like putting on an incline, branch at some angle, and watch it slide constant velocity. Okay. Procedure, just a handful of steps. The setup, what do you measure with one or the other measuring tool? Analysis, what did you do with those measurements? Right. So that you can conclusion, and conclusion should answer your question. The question is, what's the coefficient of friction? Right? We're doing those 2 different ways. It's really like 2 different labs. Right. But pick your favorite way. Do a 5-part write-up, and then at the last about 5-10 minutes of class, I'll go through a score with you guys, right? So for now, just go ahead and focus on just this one. Keep a pretty good pace. I'm gonna stop the video, give you guys time to get some data, graph as much as you can, and then I'll restart the video a few minutes in and help you guys out here.